Welcome to your first video notes. I'm going to go very quickly because most of you already are familiar with how this works. So what you're going to do is in your notebook, basically what is on my screen, you're going to write down in your notebook, and this is your title. Make sure you title your first notes, Unit 2, Polynomial Sketching Polynomial Functions, and your subtitle, which is Example 1. First things first, always want to annotate anytime we see a question in math, so that way we are strategic and purposeful in our work and not doing extra things when we really don't need to. All right, so we're going to sketch a graph of the function f of x equals x cubed plus x squared minus 9x minus 9 by finding the zeros and determining the sign of the function between zeros. Explain how the structure of the equation helps guide your sketch. Cool. So key things that are popping out for me are sketch. That means we don't need to be exact, but getting a rough estimate here. This is our function that we're working with. We also want to take note of the zeros. We want to figure out what those are. And we also want to figure out the sign of the function between the zeros. All right. So, and then afterwards, we want to give a little explanation. Great. Couple of things before we also even get started that we want to start thinking about. In this piece, you won't always have this. I won't always give this to you. But as we are learning a couple new concepts, these are a couple of questions that you want to start asking yourself as you are thinking when sketching a polynomial graph. Some predictions, basically, are the things that you want to start thinking in your head. What is the degree of the function f of x? How many x-intercepts are there? How many local extrema are there? What's really nice whenever we have something in standard form already is that we can look at the leading term. So right here, this is our leading term. So x cubed, right? And remember, there's a 1 in front of here, so recalling that is your leading coefficient. So we can actually, just from this leading term, we can find out so much information already about how our graph or sketch is going to look like. So what is the degree of the function? Well, the degree is the highest exponent out of all the other terms. So it happens to be 3. So it's 3. Also, because it's 3, there is a connection between the number of x-intercepts and the degree. That means usually that they are the same. So I'm going to make a prediction and say that we're going to have possibly 3 x-intercepts as well. Local extrema, how many are there? In this case, it's usually always 1 less than the degree. So in this case, 1 less than 3 is 2. So possibly there's going to be 2 hills and valleys for this problem before we even sketch. Lastly, we also learned recently that this is an odd function. So that means it's going to act a little differently. So most likely it's either going to take one of these forms. It's going to look either like this, or it's going to look either like this, kind of like these type of shapes. Okay, how do you know which one to pick? Well, it's dependent on whether or not it's positive or negative. Our leading coefficient right here is positive. Okay, so most likely it's going to be this one because it starts at negative infinity and ends at positive infinity. All right. These are all these things I'm annotating right now are all just happening in my head before I even start the problem, right? So if you're being strategic in class, this is what you want to be thinking about before you even start sketching. All right, so let's go ahead and answer the first part, which is finding the zeros. So I'm going to go very quickly, and again, as I am writing, you can pause the video and rewind or however you'd like so you can catch up or copy down again. So, but I am going to go quickly during this part because we've seen this multiple times. So here we have a 4-term polynomial. Last time we were given a factor and we were able to divide. In this case, we don't have a 0. We don't have a factor to work with. So most likely our go-to is factor by grouping. All right. So in this case, we're going to group the first 2 terms together and the last 2 terms together. And we'll get x squared as the GCF. So we have x plus 1. And then the GCF for the next binomial should be -9. and what we have left over is x plus 1. Lastly, we look at the second row. What is something that they both have in common? And that is x plus 1 and x plus 1. And we can go ahead and factor that out, and we'll get x plus 1, and then whatever's left over, which is x squared minus 9. Okay, so whenever we're finding zeros, it's always easier to factor completely. So usually you want to get a binomial, but with a leading exponent of 1, and in this case we have a 2 here, so this most likely can be simplified, and we're going to try to do that, and we can because it is a difference of squares. And that is how our function would look like in factored form. So we have factored form. Okay. This is going to be important, so I'm going to go ahead and highlight this as well. And great. So factored form is always the nicest and easiest version that I like to see our functions in. It usually gives a lot of information in terms of finding out the zeros. Standard form is great in finding even more information, such as the x-intercepts, local extrema, degrees, etc. Okay, so here we want to find the zeros, so we go ahead and use zero product property, or ZPP, and we set them each equal to 0. And we should get x equals -1, x equals 3, and x equals -3. Great. So you can go ahead and annotate your work. These are the zeros, which are also going to play a role, specifically being the x-intercepts. Great. So moving on, we have here below, it says at which x values can the function change from positive to negative or from negative to positive, right? So in class we did highlight this already, but which x values? Well, lo and behold, what did we find? We found the x values. Woo! Okay, great. So now that is exactly what we're referring to. The x-intercepts are the values that change the function from being positive or negative, right? So we're making all of these connections, all this algebraic piece to find where is it above the x-axis and where is it below, okay? So let's put some pictures to what I'm referring to. So we have x equals -1, x equals 3, and then -3. So these values are our x-intercepts. So we're going to put this one here. This is -1. 1, 2, 3. This is -3. And then we also have an x-intercept, or a 0, at 3. Great. All of that work just to get started on figuring out whether or not our function is going to be above the x-axis or below the x-axis. Okay, so the way for us to find that is using interval notation, or just figuring out what the intervals are. Now I'm only going to do this once, but to give you an idea, we have an interval right here where it's less than -3. We have another interval between -3 and 1, so kind of like right here, roughly. And then we have another interval between -1 and 3. And then we have another interval beyond +3. Okay, so just to give you guys an idea, these are the intervals that I'm referring to. So we can pick any number in the orange section, green section, purple section, or pink section, which are the intervals. But I'm not asking you to color every time, so we're just going to be efficient mathematicians and figure this out with some notation. So the intervals can be rewritten as such. So we have x is less than -3, x is greater than -3 but less than -1, x is greater than -1 but less than 3, and then also when x is greater than 3. Okay, this piece, the interval notation, I'm not concerned about you getting this piece right. What I am concerned is you selecting the numbers in the right interval. So in this case, we want to pick a value that's less than -3. And so we're going to have -4, and a value that's between -3 and -1, we're going to pick -2. And then a value that is between -1 and 3, we're going to pick 0. And then a value that's bigger than 3, and we're going to pick 4 because it's easiest, and it's the next number. So all of these are inputs, right? And that means we're trying to find a specific output. And what are we going to use to input, or to basically substitute all of our inputs, right? So we're going to actually go back in using the factored form of our polynomial. We could use standard form, but if it's in factor form, we are able to do some more mental math a little easier, and it lessens errors, okay? So this is going to take some time, but basically I'm just going to copy the structure here, and I'm actually going to be writing, unfortunately, on my graph. But usually what I like to do is show the work here to show what I am doing, okay? So then, in this case, we have +1 - 3 + 3. Okay, so +1 - 3 + 3. Okay, and so basically I'm going to rewrite this blue structure every time, and then here I'm going to write -4, -4, -4. And so then I have +1 - 3 + 3 +1 - 3 + 3 +1 - 3 + 3. Okay, and then here I'm going to basically substitute all the inputs that I have. So I have -2, -2, 0, 0, 0, 4, 4, 4. Great, cool. That piece takes a little time because you got to sit there, you got to write it, you got to double check your work, make sure that you have the signs matched, all of that jazz. Okay, so once you do that, you have a lovely handy dandy calculator that can calculate all of these things. And so what is the output when of f of -4? You should get -21. And then what is the output f of -2? We should get 5. What is the output of f of 0? We should get -9. And then lastly, what is the output when it's f of 4? We should get 35. Now, the numbers aren't necessarily what's important here. What is important is the sign. So we get a -21. So we're going to take note of that. It's negative. We have a +5, and then we have a -9, and then we have a +35. These signs are the ones that will determine whether or not we're going to draw or sketch our polynomial above the x-axis or below. Okay, so it starts at a negative. So in the interval, x is less than -3. That means it was in this section here. It's going to go below the x-axis, right? And then between -3 and 1, we say it's positive. So it's actually going to be positive, okay? It's going to go above. And then the next interval is negative, so we're going to start below. And the last interval is positive, so it's going to go straight through and be above the x-axis. So think of this as this is below, this is above, this is below, and this is above. Okay, so that is how we are able to find the signs algebraically. This takes some time, but that's how we do it. Cool. So remembering this is just a sketch, and this is what we're looking for when we see the sketch here. Again, you do not have to write the interval notation, but you should be able to be strategic about which inputs to select using the zeros or x-intercepts. Oops. So as a conclusion, what I would like for you all to do is write at least 3 key ideas or concepts from this video that you have, and then write 1 question that you still hold about some of the topics addressed in the video. And that can be part of your summary here below. All right, and that's it.